Oh no! All right. Now, before we go on, there's something I must mention. An important message that I must bring to your attention. That's from a song. I didn't make that up. None of you have heard that band, so it doesn't matter. Suicidal Tendencies. They are a very hard rock band with a singer that raps. Yes. Do yourself a favor and listen to some Suicidal Tendencies. They're really cool. And if you don't quite dig them, the singer has another band that is more kind of called Infectious Grooves. If you want to give them a listen, they're really cool.
Yeah, like those two band names sound interesting, special.
We don't have time. I'll show you some later. All right, so anyway, important message I must bring to your attention. Yes, to do this, you need to know what a prime number is. What is a prime number? Yeah, that'll do. A number that can only be divided by 1 and itself. So, 2, which is the most powerful prime number. Why?
Because itself is the number it can divide by itself.
Not quite. It is the most powerful prime number because it is the only even prime number. Right? Because every other even number 2 divides into, so they can't be prime. 2, 3, 5, 7. What's next? Everyone says 9 because I always write it out that way. It's 11. Then what?
17.
Then what? 17. Then what? 19. Then what? Then what? No. 29. Then what? 31. Excellent. Now, there is no pattern. There is no formula. They occur randomly. The largest prime number is something up in the billions, which is pretty amazing to me, that you can have a number with that many digits, 9 digits, and have it have no factors except 1 and itself. I can't quite remember what the largest prime number that we have discovered is, but just for fun. All right, so we all know what a prime number is, yes? We will very rarely need prime numbers bigger than about 13, 17, 19-ish for our purposes, okay? All right, so we know what a prime number is. Prime number is any number with only 2 factors. What's a factor? Right, and with 2 factors. And those factors are 1 and itself. We remember that a factor times a factor gives me a product, which means that factors, as Jalem just said, divide into the product. Yeah? Yeah. So, back in about grade 5, Mrs. Bad Crumble had you make factor trees. You have seen what I am about to do at some point in your math career. But in the 5th grade, this was all you did. You finished your factor tree, Mrs. Bad Crumble looked at it, gave you a gold star, and you were like, yeah! And you thought it was over. And Mrs. Bad Crumble never showed you why you would ever use this skill again. Until now, grade 10. So 6 years ago it was shown to you. Now you're expected to remember it and use it, which is silly. But that is not your fault. It is not my fault. And it is not Mrs. Bad Crumble's fault. It is the way the people who tell us how to teach you math have told us to teach you math. Okay? So let us do that. Now, there is more than one way to create a factor tree. Mrs. Bad Crumble most likely worked downwards. And what she or he said was, what are two numbers that will divide into 54? And most of you are going to say 9 and 6. Most of you. Now, are either of those factors prime numbers? No. So since I want prime factors, I have to keep breaking them down. What does 9 break down into? 3 and 3. Are those prime numbers? Yes. So every time I get to a prime number, I circle it. What is 6? 2 and 3.
We're not doing it that way where you have 2, 3.
Everyone see this? All right. So now I have all of my branches ending at circles, yes? So how many 2's do I have? 2 times how many 3's do I have? 3 cubed. And that equals 54. Because 2 times 3 cubed is 27, and that equals 54. Is everybody good?
I get it now. I wrote 27.
Those aren't factors. That's adding.
Oh, yeah.
Everybody good? All right. Now, what do we do with 162? Same thing. It's a bigger number, though. It ends in 2, so what do we know it divides by? 2. And then that's going to give us 81. How would you break down 81? 9 and 9. Are either of those prime numbers? No. So you would break them down further, and you would get to the end, which is 9 and 9. Oop, those aren't prime numbers, idiot. 9, 3, 3, 3, 3. Prime, 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 prime. 2 times 3 to the 4th is 162, because 2 times 81 is 162. I should have changed colors there. Does everybody see how it works? Now, there is more than one way to make a factor tree. You can go horizontally. I don't care. You can do what I was taught, which is this, and I'm going to do that in gray just to show you. 162 divides by 2. 2 goes into 16 8 times, leaves me with a remainder of 0. Or 2 goes into 2 once. Then 3, which is, Then 3, which is 27. Then 3, which is 9. Then 3, which is 3. And your prime numbers all live out there. I don't care what you do. The skill is division, right? How you draw it, I don't care. Everybody with me? All right. Now, that is going to tell us something. What it is going to tell us is, it actually is going to tell us two things. It is going to tell us the greatest common factor, which we abbreviate as GCF. The greatest common factor is the largest number that is a factor of both. I don't want to say both. Change that. Of all the numbers which you are comparing. Okay? So right now I'm only comparing two numbers. So I'm trying to seek the largest number that is a factor of both of those numbers. All right? A GCF can be found using prime factorization as follows. You list all the prime factors that occur in your factor trees. That occur in your factor trees for the entire group. All right? So, I'm going to work in black because we're going to be finding the GCF. What were the factors of 54? 2 times 3 cubed, right? That equaled 54, yeah? And what were the factors of 162? Which is 162, right? Now, to find a GCF, I must list all the prime factors that occur in the factor trees for the entire group. So, is 2 in the factor tree for both groups? Yeah. Yes. So if I'm going to GCF, I'm going to have 2. What else? 3 appears in both groups, yes? How many times? No. No. 3 times. Because it occurs 3 times there and 4 times there. So only 3 times does it occur in both groups.
Oh, you're talking about 3.
Yes. Some people actually need to write this out longhand to see why it works at first. 2 times 3 times 3 times 3. 2 times 3 times 3 times 3 times 3. What is in both groups? 1 and 3 threes, yes? 2 times 3 cubed is 54. So 54 is our greatest common factor. And that makes sense, doesn't it? Because 54 times 1 is 54, right? And 54 times 3 is 162. Does everybody understand? All right. Now, a lowest common multiple is a little harder to explain. A lowest common multiple is the smallest, not the largest, the smallest number that your entire group can be a factor. So factors are smaller than the numbers you were dealing with. The same or smaller. Multiples are the same or bigger because I'm multiplying up to them. The numbers in your group are the factors now. When have you used this already? This is how you add fractions. Except we call it the lowest common denominator, don't we? LCD, lowest common denominator. The lowest common denominator is a multiple. Everybody cool? How you find it is a little more tricky. You must count all the factors on your tree, but you only count them once. No repeats. So here's what I mean by that. I'm going to work in blue. So remember, I had 2 times 3 cubed, 2 times 3 to the 4th. If that's going to be my LCM, I have to count everything once. So, do I need to count 2? Yeah, because it's on the list. How many times do I need to count 2? Once. Because if I count that 2, that covers that guy, right? Do I need to count 3? How many times? Once? Read it. I must count all the factors on the whole tree. How many 3s are on the whole tree? 7, but I don't need to do any repeats. So, how many 3s will cover all the 3s at least once? 2 will not even cover those 3s. Yeah, you do. 7 will cover all those 3s, which means we've counted those ones twice. Okay, sometimes it helps to write it out. 3 times 3 times 3. 3 times 3 times 3 times 3. Count them all, but don't do any repeating. 4. Why? Because that's a 3. Got to count it, but I don't count it twice because it's a repeat. Got to count it. Don't count it twice because it's a repeat. Got to count it. Don't count it twice because it's a repeat. Got to count that one. So it's 3 to the 4th, which we know is 162, which we know works because 54 times 3 is 162. And 162 times 1 is 162. So 54 is a factor of both numbers. 54 times 3. 162 is a factor of both numbers. 162 times 1. Is everybody good? The math explanation is a little bit confusing until you practice it. Let's practice it.
Wait, that's the lowest common multiple?
Yes. Let's practice it.
So it's only the prime factors?
Yep. So, we're going to do the first one together, then you're going to do one, then I'm going to make a couple of changes. Well, we're going to do one, then you're going to do one, then I'm going to give you some hints, then you're going to do 2 more. Let's start with this one. So, I got 36, and I got 120. Step 1, find your factors. Don't care how you do it. Use some form of factor tree.
Do you have to bring down all branches?
Till they get to prime numbers.
Okay. I forgot everything I just learned.
I have done both methods that I have ever been taught. Has everybody gotten to there? Once, twice, thrice. Is everybody there? All right. What color did I do GCF before? Black. So I'm going to do GCF in red. GCF means I count what?
Everything.
No.
Stop.
Only the common. So, what is common so far?
2 and 3.
Right. So I know that I need 2, and I know that I need 3. Why not 5? Because 5 isn't common to both of them. How many 2s are in both lists? 2. 2 2s, 3 2s. So there's 2 in both lists. How many 3s are in both lists? 1. 2 squared is? 4 times 3 is? 12. So my GCF is 12. Everybody good? Now, LCM I'm going to do in blue. LCM is everything but no repeats. So, I know I need 2, I know I need 3, and I know I need 5. How many 2s will cover everything? 3. Because there's 3 2s there. So I have to count all 3 of them. How many 3s will cover every 3? 2. Because there's 2 3s there. Those 2 will cover this guy. Times 5. What is 2 cubed? 8. Times. What is 3 squared? 9. 72. Times 5. 360.
Oh, I get it. When you mean no repeats, you mean you don't have everything.
Right.
Okay.
Everybody got it? Great. You do B by yourself. And I'm going to give you a couple of tricks that help when the numbers get bigger.
Oh, I got this math song stuck in my head for multiplication tables. Now I was going to use it. You're lucky fired up.
Does everybody have an answer? Don't say it out loud. Just, if you have an answer, tug on your left ear. I saw at least one person grab both ears and had to think about it. Left ear. The one where your fingers make an L. Yeah.
I get it now.
Who would like to offer their answers?
I don't have a second answer.
Take a moment and get a second answer, Mr. Pearson. Who would like to offer their answers? Come on, don't be like that. Harmon, what are they?
GCF 6, LCM 72.
Yes, GCF is 6, LCM is 72. Dun, dun, dun.
I only did LCM.
Does everybody see why? Where are you lost, Lena? Can you do this? Can you make the groups?
I did the 18 differently, I guess.
Yeah.
Oh, so for GCF, it's got to be, you have to have a group.
It has to be common to both of
It's got
them.
to be common and a group.
Is everybody good?
There's only one group to choose, and only one.
Everybody's good? All right. Now, I want to take a moment, and you don't need to write this down. because I don't usually do this for you. This is really easy if you know your times tables. And when I say know your times tables, we've had this discussion before, I mean you have them memorized. I mean I say any two digits between 2 and 12, and before I finish saying the word equals, you already have the answer. If you know your times tables that well, then you are good enough to ignore the little tricks I'm about to tell you. Practice right now, okay? 3 times 7 equals. 5 times 6 equals. 7 times 11 equals. 8 times 12 equals. 96. All right. So most of you guys are already where you need to be with your times tables, right? Most of you are pretty good at them. 6 times 7. 42.
Which one is that?
8 times 7. Now, all of you were given a million little tricks to remember your times tables, right? The one for 9, count your knuckles. And the other one, if it's 9 times 6, then the answer is the second number minus 1. And then, 9 times 6 is 54. The second number minus 1, and then whatever adds to that to make 9.
What?
9 times 6 equals 54. The trick that kids are taught is it's always 1 less than that, 5, and then whatever adds to 5 to make 9.
I would have gone 10 times 6 minus 6.
I would have gone, use some flashcards and memorize your times tables.
But that would
I know, I understand. There's a way to do it. There's all kinds of tricks. I know, right? But for some reason in Canada, we like to teach these silly little tricks. I don't know why. Well, I do know why. Because if you're not good at memorizing stuff, but you're taught to memorize stuff, then when you can't memorize it, it seems like you don't know how to do it. And then it seems like you're dumb. But you're not. You're just bad at memorizing, right? You wouldn't consider someone was dumb if they couldn't play the violin, right? So that's why we do it. I don't like it. But anyways, let's say you're not super hot at your times tables. I'm going to give you a couple of tricks for dividing. Some of you know all these already. Some of you will know some that I don't know because I didn't learn any of these tricks when I was your age because we learned our times tables. So, if something divides by 2, then the number ends in 0, 2, 4, 6, or 8. Anything that ends in 0, 2, 4, 6, or 8, you can automatically divide by 2. Okay? You already know that one. A number will divide by 3 if the... Does anyone know the one for 3?
3, 6, 9.
Nope. Right. If the digits add up to a multiple of 3. So here's what I mean. 143. 1 plus 4 plus 3 equals 9. Is 9 a multiple of 3? Sorry, 144. It's all right. Is 9 a multiple of 3? So that means 144 will divide by 3. Everybody cool? All right. If it will divide by 5, it ends in 0 or 5.
So there's no rule for 4.
1 second. I'm only doing the ones I know. Other people have others. I don't know these because I never learned them. Right? If it divides by 2 and divides by 3, it'll divide by 6. After that, I don't know anymore. If you know some, I'm willing to listen. Oh, yeah. Divides by 10 if it ends in 0. I don't know. I don't know. I don't want to bother. I just know my times tables. This is enough to get you through. Does anybody know any more? Harmon says there's one for 9. Does anybody know it?
Did you just say it?
No. It's something to do with this. It has to do with adding up the digits.
9 by 3, take away the 3, 2, 7, 27.
Yeah, but that doesn't work if you're using 984.
Like
Well,
if
we
it
should
was,
look it up.
No, I'm not going to look it up because I know the times tables.
yeah, it's the last 2 digits have to add up to 9.
If the last 2 digits add up to 9, you can divide by 9?
Or if it's a
Well, let's think.
multiple of 9.
Yeah. If the last 2 digits are a multiple of 9, you can divide by 9? Really?
Genius.
Well, let's try.
154.
Well, no. Yeah. Does 154 divide by 9? 9 goes into 15 once. 64? No.
No.
Not that. So it's not that one. Oh, 54? Yeah, no, so it's not that. Anyway, see what I mean? These little tricks are confusing us. Ignore them. Learn math.
Oh, with 9, I have, yeah, now that one.
What is it, Amy?
Well, exactly. It's when you go, so you start at 9, and the other one you start at 1. So you, okay, I don't know how to explain it.
Good. Stop. If it's too hard to explain,
No,
it's not a trick
not
worth
hard to
learning.
explain, but I can't think of the English thing. Anyways, if you start 9, 1, 8, 2, 7, 3, 6, 4. So you go like for 9. You see, like it's so you go 9, 1, 8, 2, 7, 3, 6, 4.
No, that's to learn the times table. That won't help us for what I'm talking
But
about.
it will help you if you have like a problem with any between.
So I know I'm talking about whether or not the number 373 can divide by 9.
Well, it's just a calculator.
I know. All right, so forget it. All right, now stop. I'm going to make a small change here.
Uh-oh. Uh-oh. What would you... Wow. What number is that? L15?
25, goof. Now you have a group of 3. Do you think the rules change? No, except now you've got to draw how many factor trees?
So many.
3 instead of 2. And we're going to do this one. And we're going to add 96 to that list. Go. Now, of course, while you were going, I am also writing it on here. The screen is just blank, so it is all going to be on the video.
What number are we adding for D?
For D, you're adding 96. All right. Is everybody done diddly-un? Would anybody like to offer their GCF and LCM for letter C? Going once. Damaris, hit me.
What?
And? You are correct on one of those.
The GCF would not be 15 because that's not going to 25.
15 does not go into 25. It is 5. Would anybody like to offer their GCF and LCM for D? For D money. Show me D money. I got you, Jadwinder. I saw you laughing. It's like a rock over there, that Jadwinder. He could be one of those guards in England. 420? Is it? Check. It's easy to check. There's no reason to...
No, 96 does not go in.
Right.
Wait, where's 96?
Right at the end. We added it.
Oh, I didn't see that. My bad.
You were dancing.
No, because he wrote it like it was dark.
Nobody?
The GCF for D?
Yes.
7.
7?
Yeah.
7 goes into 96?
Wait, D? Mine has 35 and 84.
And then I said we're adding 96.
Oh, D.
So if we just add 35 and 84, it would indeed be 7.
Yeah.
But since 96 is part of the party, it can't be 7. What is it? What's the factor that's common to every number? 1. GCF is 1. What's the LCM?
Couldn't tell you.
3,360. And that's how they work. Is everybody good? Now, unlike previous math, we are going to use both of these. One of them, we're going to use this unit immediately, and the other one, we're going to use next unit. So you will use them right away, not 6 years from now. Okay? Everybody Gouda? All right, now listen, it's 10:12. Oh, son of a... I had my finger here, and then I leaned forward in the chair. Ow! I don't need it checked out. I'm not a wuss. It hurt a little. I'll be okay. Because it hurt a lot. I'll still be okay.
You're crying, bro.
Well, you come over here, you put your finger, I'll lean forward.
Why would I do that?
Exactly.
I'm not dumb, bro. I know what to do. I'm not coordination.
Okay.
Look, you see this shirt posting? Reflex.
Uh-huh.
Simple.
Okay. Yeah. I do see it. Easy peasy lemon squeezy. So as I was saying, it's 10:23. Here's what. I want to do a couple of things. One, I forgot to ask if everyone was okay with page 112.
I did that too.
You had all the answers. I just want to make sure everybody understands why those answers are what they are. Was everyone okay with 112?
Yeah.
Number 10? Number 20? Yeah. Anybody else?
Wait, what was the LCM for D?
3,360. Did anybody need to talk about anything on page 112 other than 20?
I didn't see that.
18A.
Oh, yeah. This one's easy.
So you got to use a calculator to get that, right? All right. So what math is happening there? It's division, right? Now, I'm going to change this up a little. I'm going to write this as x and this as y. So, if you were going to punch that into your calculator, you would have to punch in the number for x, then divided by the number for y, right? All right. But this x, something's happening up there, correct? This is saying this whole thing divides by 2. So what must you do with your calculator to keep something together? What math groups stuff together? What math symbol?
Plus.
Nope.
Multiplication.
Nope. Brackets. So what is happening here really? You must do bracket 1 plus the square root of 5, however your calculator does square root of 5, close brackets, divided by 2 equals. Okay? Okay. Because if you don't put those brackets, your calculator does BEDMAS. And if you don't put those brackets, you are doing 1 plus the root 5, then you push divide by 2. What does your calculator do first? It does the division first. Okay? Anytime you see an expression with division and there's something going on in either the top or the bottom, you got to do brackets. Okay? Anything else from page 112? Yeah? All of you can explain number 6? Everybody can explain number 6.
What is that? It's irrational because the decimal doesn't work.
Why is the first one rational? Because it says right in the answer, 6a is rational. Because this number, when we write it out, ends there. But if we push square root 150, what do we know about that number on our calculator? It's going to keep going because 150 isn't a perfect square. So it is irrational. Everybody gets the difference? Okay? And technically, if we were to square that, observe, on,
You have to push on for a digit.
on,
That is weird. Should already be on.
12.247 44871 squared. Notice it does not actually equal 150. Does everybody get this? All right? But if I do this, square root 150, and I fill up my screen, and then I do this, wait a minute, bracket, square root 150. So square root 150 squared, what am I going to get? 150. Because the square root of 150, this number actually goes on forever. Is everybody cool with that very subtle difference? If I were to have drawn this son of a motherless goat, if I drew this way, it ended in 1, and I drew this. Now is A rational or irrational? Irrational. Does everyone get it? Sweet. Okay. So now we are here. You are going to work on page 115, both sides of it. While you are working on page 115, I am going to get the solutions going to the 2014 contest that you practiced yesterday. Hookily dockily? Hookily dockily. I gotta find a paper one so I can actually do them. I don't know if I have a copy of it. Oh, I know who has a copy of it. Mr. DeVries has a copy of it. Not that Mr. DeVries, big Mr. DeVries.